A very good morning to one and all.
Good morning, sir.
Yeah, how many students are joined? Around 42 students. Can I start? Hello? My voice వినిపిస్తుంది అందరికి?
Yes, sir.
Hello? Okay. Any disturbances coming from my side?
No, sir.
Okay. My voice is clear to all. Okay.
Yes.
Yeah. Very good morning to all. So after a long time, we are conducting DBMS classes. After the completion of your exams, two exams, we are conducting classes, right? So I hope all are safe and healthy. Hello, all of you safe.
Yes,
Yes,
sir.
sir.
Yeah, yes. So did you get DPMS lab timetable? So did you get labs timetable from our college or
So
from our
January
department?
6 days కోసమేనా
Intama?
జనవరిలో 6 days ల్యాబ్స్ అవేనా సార్
అదే.
ఎస్ సార్
Okay. Okay. So I'll start the class. Today's class is this is very important to your exam, your final exams, and your campus interviews also. So the topic is that normalization. So basically, the normalization is a one of the technique to use schema refinement. For suppose what is schema? For suppose if you want to write a schema, schema, employee, how to write employee id, employee name, and employee salary. This is a schema of the employee, right? Right. So in employee table we have employee id, employee name, employee salary. These three are the fields of the employee. It has their own values. Employee id having some values, e name having some values, and e salary having some values. So here, if you are when you are inserting values inside the database, it may be distinct values are there, it may be duplicate values are there, it may be some other values, null values are there, right? So based on that values, we have to apply some normalization technique, right? Normalization means it is a technique which can be used to remove the redundancy from the database, right? Look at here. So look at here. Screen is visible to all. Hello.
Yes, sir.
Hello.
Yes,
Hello.
sir.
Screen is visible.
Yes, sir.
Okay. Yeah. So here, this is normalization. Basically, the definition of the normalization is that we can remove or reduce the redundancy from the table, right? We have two tables. This is first table. This is a second table. If you observe this table, first table, the first row is that 1 RAM and 20 is there, and third row is that 1 RAM 20 is there. This is the same data is replicated two times, right? This is right. So this is row level duplicacy. This is row level duplication. So whereas in the case of second one, if you observe, so SID is a primary key because all these values are unique, and S name, Ram, Ravi, Nitin, Amit, all these are distinct values. No need of no problem for this for these two attributes. If you observe here, so C1 DBMS F1 John 3000, C1 DBMS F1 John 3000. So at the same time, the third one is that. So course ID is C1, course name is DBMS, and the faculty ID is F1. faculty name is John, and salary is 30,000. These three are same values. So which means that this is not affected entire row. This is affected a part of some table. So that this is column level duplicacy. Column level duplicacy. So this is row level duplicacy. This is column level duplicacy. So if you maintain, so what is the final solution for this? So we have to maintain some primary key for this table. Primary key means unique values, right? So if you maintain primary key, it will not repeat the second duplicate table. So and duplicate row 1, RAM and 20, right? So this is the solution for this primary key plus a unique plus not null and etc. If you maintain some constraint to this particular tables, we can reduce redundancy, right? So the second table, if you observe C1, 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 three rows are there. So because of this column level duplicacy, we have three different types of problems are there. The problems are some anomalies, right? The anomalies are, it may be insertion anomalies is there. It may be deletion anomalies. It may be updation anomalies. For suppose if you observe the insertion anomalies, so insertion anomalies are, see, these are the anomalies because of this redundancy of column level redundancy of the data, insertion and deletion and updation. So we have to see one by one how the redundancy is occurred, how the problem is occurred inside this insertion anomaly. For suppose if you want to insert the values, so there is no for suppose student 5, some Raja, right? So the course ID and course name not yet decided, and faculty is not yet decided. So this entire columns data is not yet decided, but course IDs and student name is decided. If you are inserting values inside the table, except these two, we have to insert all these values are null. This is one of the insertion anomalies. The table should not contain null values, right? Or the admission is not there. The admission is not there. Courses are decided and faculty also available, right? So without student, there is no course. And if the students are not there, the course is available. This is also insufficient data in column level duplicacy, right? This is one type of insertion table. Whereas in the case of deletion, how to apply this deletion anomalies. For suppose if you want to delete the column 1 C1, based on this SID, we can delete this entire row. Delete from which table? So for suppose student table, delete from student where SID equal to 1, right? We can delete directly. So this first row, because there is no SID 1 to the remaining students, right? So whereas in the case of a CID, course ID, if you want to delete the data based on the course ID C1, so delete from student where delete from student delete from student where CID equal to C1. CID equal to C1. If you apply this one, automatically we can delete those rows which are having C1 values. So this is deleted, this is deleted, this is, but I wanted to delete so this first row instead of this one. So because of selection of this course ID, we can delete all the three rows from the table. So this is about deletion anomalies. So whereas in the case of updation anomalies, right? So whereas in the case of updation anomalies, you look at here. So CID, the CID is C1 and C1 and C1. Three C1s are there. If you want to change the faculty of C1 based on C1, right? Faculty name. How to update? How to update update the table, student table, student. So update student, set what we have to do, set FID equal to, so what is that, where FID equal to some F2 where where CID equal to C1, right? So if you write updation table for this table, so wherever C1 is there, we have to replace faculty F2. Automatically I wanted to update this first row instead of this one. Because of this query column level duplicacy, we are updating all these three values, right? So this is for column level duplicacy problem. First one is insertion anomalies, updation anomalies, and third one is deletion anomalies, right? So these are the anomalies already we have discussed, and how to remove all these things from this different types of row level tables and column level table. We have different types of um, techniques are there, that is normal forms. So the normal forms are different types of normal forms are there. Normal forms is that normalization is the process to remove the redundancy from the table. So for that process, we have to use different types of normal forms. One is 1NF, 2NF, and 3NF, and 4NF. The first 1NF means first normal form. We have to write first normal form. In examination, there may be chance to ask 1NF for first normal form, and 2NF for second normal form, 3NF for third normal form, and it's a BCNF is a Boyce code normal form. Boyce code normal form, right? Right. So this is yeah, about these four types of normal forms in normalization techniques. We have to see one by one. The first one is first normal form. So the first normal form is that what are the different types of normal form uh, are there, right? We have to see the first normal form. What is first normal form? The basically the database management system, the father of the database management system is EF code. The EF code is introduced different types of normalization techniques. The normalization techniques is first normal form. The first normal form is that, so what are the rules of first normal form? We have so the table should not contain any multi-valued attributes. The table should not contain any multi-valued attributes. For suppose for suppose right. So if you see here, so this is a first normal form. A table should not contain any multi-valued attributes. You have to concentrate on this multi-valued attributes. For suppose this is the student table, roll number, name, and course is there. This is primary key 1 2 3. So the second one is name, Sai, Arsha, and some other name is there, right? So the next one is, so course, the Sai is joined in C and C++, and Harsha Java, and some other person is C and DBMS. According to first normal form, w- the table should not, the table attribute should not contain multi values. So if you look at here, C or C++, Java, so C or DBMS. According to this rules, so this is valid statement. This is a valid statement. But these two are not valid statements. Now I need to convert this. This is not in 1NF, right? This is not in 1NF. Now I need to convert this non-NF, non first normal form into, so the first normal form, right? So what are the techniques which can be used in first normal form is that, so what are the chances are there, what are the solutions are there? The first solution is that, so we have to split that multi values into some other rows. So first Sai and so C, and same values, roll number and name, C++, Arsha. The next one, next three values are duplicated with 3 3, right? So here so this is a first solution, this is one solution, right? So if you maintain the solution, it has some duplicacy is there, one side and one side these two are repeating two times, and these two are repeating two times. So this is one type of solution, right? So still we have redundancy is there. So the second solution is that, so instead of maintaining separate row for this course, we have to split one column extra, right? Column 1 and column 2, one Sai C C++, 2 Harsha Java. So here the Sai is studying two courses C and C++. The Harsha is studying only one course. The second course is set to null, right? And the Harsha did not join second course, so that it's set to null, right? Then the third one is, so three some Raja is there, and C and DBMS, right? In the same way, so C and DBMS, two courses are joined. So this is a second solution, right? So the next one is that the third solution is one more solution is there. So if you right, so the third solution is that, so what is that third solution? We have to maintain two tables. This is one table, so this is one table, this is another table. Already we know that the foreign key and primary key relationship, this is another table. So the first table, roll number and name, and the second table also roll number and name, what is that, course of the table, course of the table. So in first table, so it has a primary key, this is a foreign key. So this is the relationship between these two tables. So we have one, two, three. These are the roll numbers of the table. The first roll number is belongs to Sai and Harsha, and some already we have taken some Raja. So these three are names of the roll number 1, 2, 3, right? This is primary key table, parent table, or base table. Next type the foreign key table consisting of some duplicates, 1 C, next 1 C++, and 2, what is that, Java, and 3 C, next one 3 DBMS. So this is the third solution, this is the third solution, right? So we have three solutions. The first one already we have seen, the second one also, we have to split extra column for this subject, and the third one is this is the final solution for this. So we have to maintain two tables. The first table is parent table, and the second table is child table. So based on that, we have to insert the values inside. Already this is defined. Now when you are inserting values into that this child table, the roll number is taking as a reference from the parent table and inserting values inside this table. So this is for according to first normal form, a table should not contain a multi values. If you observe here, so if you observe here, the table are not having any what is that, not having any multi values. If you see here, these are the different values, and the attribute should not contain any multi values. And so even though these are duplicate values, it has separate columns only, atomic values, right? Whereas in the case of first one, so this is also atomic values are there. Atomic values means each and the row should be the values are separate rows, right? This is also different, right? So this is about first normal form. This is about first normal form. So if you observe this one, this is also each and every row contains their own values. Even though it has duplicate values, according to first normal form, the table should not contain multi-valued attributes, right? This is for this is for uh, first normal. This is for first normal form, right? So here the second normal form is that the second normal form is that what is second normal form? Before going to second normal form, we have to know about the primary basics of the second normal form. So this is also very very important for your exams. So how to find a closer method um, for this functional dependencies, right? So, if you observe here, so which means that the finding of a closer means we have to find the candidate key from this functional dependencies, from this functional dependence. How to find that? Very very easy. See, look at here. So if you these are the functional dependencies: a tends to b, b tends to c, c tends to d, right? I need to find candidate key from this table, the table fields are a b c d is there. So how to find a closer? I need to find a closer a plus. Closer can be represented with a plus attribute with a plus, right? So a plus. How to find this a plus? A plus means a plus means so what is the functional dependency for um, a tends to b is there. A can be derived b next. So b tends to c is there, so that we have to place with b. C tends to d is there, so we have to place d. A itself, a reflexivity property is there. The closure of attribute is itself derived one more attribute. This is so a. So that a b c d, what are the given table r of a b c d is there. So that we have to conclude a is one candidate key. So that candidate key ck equal to a. So not only this one, we should not finalize. Once you find this one, this is for candidate key, we have to find remaining three remaining three attributes also. So what about b closer? B tends to c is there, and b tends to b, b tends to b itself, b is there. So that b tends to c is there, c tends to d is there. So there is no a is missing. So that we should not place a tends to b. So which means that b is derived by a. So so that we have to write b only, you should not write a here. So here a is missing, the actual table is a b c d. So that this is not B is not a candidate key. So if you observe third one, C plus, automatically this is itself one functional dependency. C tends to D is there. So this is one of the closure property. But if you compare this one, so AB is what is that? AB is missing. So that this is not a primary key. If you observe a D plus, D itself D, there is no functional dependencies for this D. This is not a function. What is that? Candidate key, right? So finally we have to conclude to see the candidate key is A. And next we have to check one more chance. AB plus is candidate key. And AB plus means we should not uh, divide this one. AB plus means AB itself one type of reflexivity property. So AB is there. So here a tends to b already is there, and mutually you have to see b tends to c is there. So that c, and c tends to d is there. So we have to divide c. This is a b c d. So a b c d is there, but a b plus is a key. But so the part here we are finding a is a primary, a is a candidate key, right? So according to this candidate key principle, this is minimal of the set, right? So overall a b is a super key, super key. So from the table, super key, from this table, so we have to find minimal attribute that is a. So that we should not take ab as a candidate key, we have to take a as a candidate key, right? So here this handed candidate key is capital A. So we have two attributes are there, non-prime attributes, prime attributes and non-prime attributes are there. So prime attributes are So key attributes, that is A is there, candidate key is prime attribute. Non-prime attributes are what are the remaining attributes? B, C, D. These three are non-prime attributes. Non-prime attribute, right? So now this is about how to find candidate key for this table by using closure property, right? If you see here, the second problem is that R of A, B, C, D. These are the functional dependencies, right? I need to find a closer. We know that how to find a closer. A plus a itself, one closer is there. A, even though a tends to a is not there, we have to write a closer means a tends to a, one transitivity problem is the property is there, we have to write a, right? Next a tends to a is the a tends to b is there, b tends to c is there, c tends to d is there, d already, d tends to a is there, already a placed, right? This is compare with the original table. So a plus a is one candidate key. Next we have to check b plus, b tends to b is there, b tends to c tends to d, and d tends to a. This is also actual table, we got actual table. B is a b also candidate key. And similarly we have to find c and d, so that the candidate keys are a, b, c, d. These are the candidate keys. So finally, what are the prime attributes? Those are keys inside the table, and that keys are prime attributes. So the prime attributes are a, b, c, d. What are the non-prime attributes except these four? Actually original table a, b, c, d is there. All these are prime attributes. In non-prime attributes there is no non-prime attributes, so that we have to maintain 5, right? This is about closer method of um, different types of tables, right? So next, functional dependency. This is also very very important for your exams. So we have a functional dependency. This can be represented by using FD, right? FD, functional dependencies. What is functional dependency? So if you write x tends to y, x tends to y, right? The x is a determinant, y is a y is called as a dependent attribute. Y is called as a dependent attribute. We have to read this combination x tends to y is x determines y, or y is determined by x. Y is determined by x. For suppose if you write SID tends to, the attribute SID tends to S name, the S name is determined by SID. The S name is determined by SID, right? So here we have to write various combinations are there. So here, if you observe here, so this is SID tends to S name. Assume some values inside the SID, some values inside the S name, right? So we have four combinations are there. So these four combinations are valid or not, we have to check here. So SID is 1, Ranjit. SID is 2, some Varma is there. So two different students with two different all ticket numbers, so that this is a valid statement, right? Valid, right? Next one, SID S name, roll number 1 Ranjit, roll number 1 also Ranjit. So even though we have two rows with the same SID and same name, there is no problem. So this is valid, right? And so if you observe here, SID tends to S name, roll number 1 and Ranjit, roll number 1 and Varma. So this is not valid. This is not valid. So we can discuss later. Next, SID tends to S name, 1 Ranjit, 2 Ranjit. So here, so 1 Ranjit, so roll number 1 Ranjit, in same class, two same students are there, two same names are there, student names are there, but SID is different. This is also valid. This is also valid. So coming to here, SID tends to S name, 1 Ranjit, 1 Varma. For suppose if you assume in your class the two different students should not have a same hall ticket number, same hall ticket number. So for suppose, so if you see here S name Ranjit, two same students, Suresh or Ranjit and Ranjit, and Raja and Chendu. Two same students, names are same, but the persons are also different. The names are same, but the all ticket numbers are different. This is valid statement. Whereas in the case of so Ranjit and Varma, these two students are different, but it has a same all ticket number. That is not possible in real world and in your class also. This is a not valid statement. So here the functional dependency consisting of x tends to y, we know that x determines y, y is determined by x. We can see one by one. We can see one by one, right? Just wait. Just wait. స్క్రీన్ కనిపిస్తుంది అందరికి? హలో,
Listen, sir.
screen is visible? Okay.
Yes, sir.
Right. So this is about functional dependency. Now we have different types of functional dependencies are there: trivial functional dependency and a non-trivial functional dependency. So for suppose we have to see trivial functional dependency. So the trivial functional dependency. If you write x tends to y, if you write x tends to y, so here then y is subset of x. Y is subset of x. This is the trivial functional dependency. For suppose if you take SID tends to SID, SID tends to SID. This is x, this is y. Then y is subset of x means SID is subset of x, right? The trivial functional dependency is always, this is always true, always true according to trivial functional dependency. Here the condition is that left hand side intersection right hand side is not equal to 5, is not equal to 5. Always it should be some amount of data should be attribute should be common, right? This is the uh, one type of condition: left hand side intersection right hand side not equal to null. For suppose if you take example, if you take SID, s name, SID comma s name tends to SID. Here left hand side and right hand side, right, SID is there, so that so it is not, right? Understand, right? Next one, non-trivial functional dependency. Non-trivial functional dependency means non-trivial functional dependency means so this is the reverse. We have to use extends to y. Y is not subset of x. Y non-trivial means trivial functional dependency. Y is not subset of x. So if you write x tends to y, y is not subset of x, which means that x intersection y equal to 5. X intersection y equal to 5. So how to derive this one? SID equal to, SID tends to name, and SID tends to uh, branch, and SID tends to phone number, So these are the about these are the examples of extends to y. This is non-trivial functional dependency x intersection y equal to 5. Right? This is about non-trivial functional dependencies. So here in this way we have different types of uh, functional properties of function. These are the properties of functional dependencies. So the first one is reflexivity. Reflexivity means if y is subset of x, if y is subset of x, then extends to y, extends to y. Already we have seen the reflexivity means this is also equivalent to what is that, trivial functional dependency, trivial functional depend. Next, augmentation. If x tends to y, then we have to write x z tends to yz. Next, transitivity, we know that A tends to B, B tends to C, then A tends to C. Like that, we have to take if X tends to Y, Y tends to Gen, and X tends to Z. Next, union. If X tends to Y and X tends to Z, then we have to common this one. X tends to, we have to union these two right side values, so YZ, right? Next, decomposition. If X tends to YZ, then X tends to Y and X tends to Z. But you should not write like this. This is invalid statement. How to write invalid statement? For suppose if the statement is like this, X tends to X, Y tends to Z. This is, we can write like this: X tends to Z, Y tends to Z. This is not a invalid statement. This is not a this is invalid statement, invalid statement, right? You should not decompose like this. This is the actual decomposition. Extends to yz, then extends to y, and extends to z, right? Next, in the same way, we have pseudo transitivity. The pseudo transitivity means if x tends to y, then wy tends to z, then wx wx tends to z, wx tends to Z. So the y is cancelled, so that we have to write, we assume that, so wx tends to z. And composition, if x tends to y and z tends to w, then we have to add this xz tends to yz, extends tends to yz. We have to add right left side variables and right side variables, so that xz and yz. This is about so this is about properties of functional dependencies, properties of functional dependencies. So these are the different types of properties and functional dependencies and closure methods we have seen, right? Next, we have to discuss second normal form. We have to discuss second normal form. Here, here the second normal form is that, if you observe here, already we have seen what is first normal form. Can you answer what is first normal form? Anybody in the class? Can you answer what is first normal form? Hello?
Multi-valued attributes must be separated, decomposed.
Yeah. If multi-value attributes inside the table is there, we have to that table is not in 1NF. We have to decompose that values into different columns, extra columns, or different rows. Actually, based on that, we can remove the we can convert into the 1NF. That is first normal form. Here, the second normal form is that the second normal form is that the table must be in first normal form, right? That is one rule. The table or relation must be first normal form. The second property is that all the non-prime attributes should be fully functionally depend on candidate key. What is non-prime attribute? What is meant by prime attribute and non-prime attribute? Can answer anybody? What is prime attribute? What is non-prime attribute? Already I told the previous slide. What is prime attribute? What is non-prime attribute? Anybody? Hello? If you answer this one, then only you are listening my class. Otherwise, all are in sleeping mode only. Hello? What is prime attribute? What is non-prime attribute? Hello, hello. What is prime attribute? What is non? You don't know? So this is candidate key already I told. Those values are keys. That is prime attributes. Those values are not keys. That is non-prime attributes. So if you here, if you A, B, C, A closer, B closer, C closer, D closer, already we found, right? All these are candidate keys. The candidate keys are A, B, C, D. Except these values, the remaining key, the remaining attributes are non-prime attributes. Here the prime attributes are A, B, C, D. So what about non-prime attributes? There is no non-prime attributes, so that we have to make, we have to keep this one 5. Whereas in the case of what is a candidate key, A is candidate key. The remaining attributes are not a keys, so that this is this is prime attribute is A, and the remaining are non-prime attributes B, C, D. Then you answer what is prime attribute and the non-prime attribute. Hello, hello. Waiting for your response only.
So candidate key can be told as prime attributes,
Yeah.
and alternate key non-prime.
The remaining are not a keys. The remaining are normal attributes. The normal attributes are also called as non-prime attributes. So here in second normal form, the table, the first rule is the table or relation must be in first normal form. The next rule is all the non-prime attributes. Non-prime attributes means those attributes are not a key values. All the non-prime attributes should fully functionally depend on candidate key. Fully functional depend on. This is another rule. By seeing this example, we can understand easily. Next, the third one is, this is very very important. The second normal form, it should not contain any partial functional dependencies. It should not contain any partial functional dependencies. So here, so here, if you observe here, we have 10 o'clock class. Hello,
Yes, sir.
what class?
CG.
CG. Okay, can I stop? I'll continue to tomorrow or day after. Tomorrow afternoon we have lab. Tomorrow afternoon we can conduct class, right? Can I stop?
Okay, sir.
Okay, okay. Chandu, did you note down that absentees names,
Yes, sir.
roll numbers?
Yes, sir.
Okay. Did you understand this normalization techniques and normalization class? I think this is very very easy and very, very important for your final exams and interviews also. Especially they'll ask only, do you know normalization techniques? The people doesn't know what is the difference between the first normal form and second normal form and third normal form and BCNF. So if you look at all these examples, we can answer easily, right? So okay. Anyhow, I'll stop the class. Time is 9:55. Okay. What is time? Okay, almost to 10. Okay, thank you. Thank you all. Okay.
Thanks, sir.